Now I love kayaks, and I love what kayaks can do for your adventures. And I'm here to tell you that the shape and the material of the kayak you choose is going to depend on what you're using it for. You see, if you're on an expedition down the Grand Canyon, then you're gonna hit some big water. Your kayak needs a lot of buoyancy. It also needs to take abuse. Now if you're racing, you want a sleek and stiff kayak that's as light as possible. And if you're creeking, you need a boat that can bounce off of rocks and is made of tough, flexible materials. And finally, if you're going to do some tricks, you need a combination of tough and light and strong and somewhat lower buoyancy. Now I have boats for all of those things. But today we're going to look at the science behind these two materials, plastic and composite.
The science of materials.
To get me started, I'm visiting a polymer scientist. To figure out where we're going. Given that this is a university, I don't think this looks all that odd. I brought with me one of my plastic boats so that she could help explain what goes into the design, specifically from the materials perspective.
Time of the boat is good time.
Yeah.
So plastics can be very, very different. They can be really tough like these kayaks. They can be really brittle like plexiglass and sort of anything in between. And they can be goo like silly putty. And they're all polymers, and that's one of the reasons why they're used so much.
In fact, this whole topic involves understanding polymers and how those polymers fold onto each other.
The reason why these boats are tough is because the molecular chains are all entangled with one another.
Polymers are basically long chains of molecules. As you can see here, if this bead represents the size of 2 water molecules, then this string is the size of the polymers in this boat. Together, it's a bit like a tangled spaghetti soup.
If I pull it, the chains can sort of slide back and forth on each other.
And that's why, for certain purposes, these plastic boats are great. It has elasticity because as it gets compressed or pressure is added to the plastic, these polymers slowly move past one another and then can pull back into shape. It doesn't break. Now, composite boats are different.
It's bad if you run into something with this kind of boat because it will break, potentially. Look at the tail. It's just like leaking.
To be clear, composite boats are made of a combination of fiberglass and carbon cloth mixed with a resin.
Filler is the fiber and the fabric, and the matrix is the resin.
In these, we're still talking about polymers, but instead of it acting like a spaghetti soup, everything is covalently bonded to each other and cross-linked, forming a really strong crystalline structure. And before we wrap up, let's look how both boats are formed. How they're made. Now, plastic kayaks are formed in a factory, kind of like this one. They're made in a giant warehouse, and it all starts with little beads like this. They put those beads into a rotomold, and then those molds are put into a furnace, heated up, spun around so the polymers are spread all around the kayak. And when they come out of the furnace, they're cooled down to make the boats we use. She also explained that composite boats are different. They're made with a cloth like this, which is actually just fiberglass or carbon fiber, and then that is actually coated in an epoxy resin. And unlike the plastic boats, these carbon fiber or fiberglass boats will never change back into their original material. In conclusion, understanding all of this about the boat's materials allows designers, like this guy, to create some really awesome boats.